Welcome to the DIY Honda Garage channel. The diagnostic trouble codes, DTCs, P0202 and P0203, indicate a malfunction in the fuel injector circuits for cylinders number 2 and number 3 respectively on the Honda Fit models from 2015 to 2020. The primary role of the fuel injectors is to deliver a precise amount of fuel into the engine for optimal combustion. If either of these injectors is malfunctioning, the engine may not run efficiently, potentially leading to stalling, poor acceleration, or increased emissions. These injectors are located on the engine's intake manifold, connected to the engine control module, ECM, which manages their operation based on various engine parameters. Any malfunction in these circuits can hinder the engine's performance and lead to the activation of these DTCs, prompting the need for a thorough diagnostic procedure to identify and rectify the issue. The DTCs P0202 and P0203 refer specifically to circuit malfunctions in the fuel injector systems for the second and third cylinders. The affected components are the fuel injectors themselves, which are responsible for atomizing fuel before it enters the combustion chamber. The injectors are mounted on the engine's intake manifold, making them integral to ensuring proper fuel delivery into the engine. The engine control module, ECM, monitors these circuits and regulates the injectors opening and closing to achieve the desired fuel-air mixture for optimal performance. With potential malfunctions in these circuits, understanding the interaction between the fuel injectors and the ECM is crucial in diagnosing the issues effectively. Several possible causes may lead to the activation of DTCs P0202 and P0203. First, a faulty injector relay may fail to supply adequate power to the injectors, resulting in inadequate fuel delivery. Second, open wires in the circuits connecting the injectors to the ECM might inhibit proper communication and function of the fuel system. Fuses are also critical. If a fuse, specifically the B1020A fuse, is blown, this interrupt can prevent power flow to the injectors. Proper troubleshooting involves identifying and rectifying these issues systematically to restore functionality to the injector circuits. Symptoms associated with DTCs P020 and P0203 may include engine misfires, which occur when the cylinders are not receiving the proper amount of fuel for combustion. This can lead to significant performance issues, including poor acceleration and an overall lack of power. Additionally, you may notice increased emissions from the exhaust, as incomplete combustion can result in unburned fuel leaving the engine. Drivers may also experience erratic engine behavior, such as stalling or difficulty starting, which often prompts further investigation into injector-related issues. Understanding these symptoms can help in diagnosing the root cause of the problems effectively. The first step in troubleshooting involves verifying the problem. Start by turning the vehicle ignition to the on position without starting the engine. Utilize the Honda Diagnostic System, HDS, to clear any existing DTCs for a fresh slate of data. After clearing, attempt to start the engine. If it doesn't start, crank the engine for a maximum of 20 seconds to ensure proper engagement. This process helps confirm whether the DTCs P0202 and P0203 reappear, indicating the presence of the injector circuit malfunctions once again. Thus, establishing a clear foundation for subsequent tests to discover the underlying issue becomes crucial. In this step, after attempting to start the engine, use the HDS to check for any indicated DTCs. If DTC P020 or P023 is visible again, it confirms that the failure has duplicated, showing that the issue persists. Knowing this empowers the technician to proceed with further diagnostic procedures. aligning with manufacturer guidelines to address injector circuits thoroughly. If no DTCs are indicated, it suggests an intermittent failure or that the system is currently operating normally. You should then inspect relevant connections, including checking for any loose or corroded terminals at both the injector and the powertrain control module, PCM, to prevent overlooking intermittent issues. The next step is to assess the injector relay. Start by switching the vehicle to the off mode to ensure safety during testing. Next, remove the injector relay from the underhood fuse relay box. With the relay disconnected, perform a test to verify its functionality. This can typically be done using a multimeter to check for continuity or operation, based on the manufacturer's specifications. If the relay tests positive, you can conclude that it is functioning properly, allowing you to proceed to the following steps. However, if the relay fails the test, replacement will be necessary and could provide a solution to the injector circuit issues. In this troubleshooting step, turn the vehicle ignition to the on mode. With the injector relay disconnected, measure the voltage between the designated test points, which involve the injector relay socket and body ground. This voltage test aims to establish that the fuel injector FI main relay output line is functioning correctly. If battery voltage is present, it indicates that the FI main relay output wire is operational, confirming that power is reaching the appropriate circuit. If no voltage appears, an open wire condition is present, necessitating further inspection and potential repairs in the wiring pathway between the fuel injection FI main relay and the injector relay. For the next step, keep the vehicle in the off mode and disconnect the injector relay. Then, measure the voltage between the specified test points, ensuring proper connection to body ground. This would involve checking the BINJ line to ensure that the battery voltage is flowing correctly. A successful measurement confirming battery voltage indicates that the BINJ wire is operational. Conversely, if the voltage reading is absent, it points to a potential problem in the circuit requiring further analysis. Additional steps may include checking the fuse or repairing any faults present in the wire segment, leading to the injector relay to maintain adequate power supply. The next step entails checking the B10 20-amp fuse located within the underhood fuse relay box. Fuses are critical components that safeguard electrical circuits by breaking the connection if excessive current flows. If the fuse is intact, it indicates that there is continuity within the +B-INJ wire between the fuse and injector relay, allowing power to reach the injectors. Should the fuse be blown, this points to either an overcurrent situation or a short circuit in the wiring, necessitating repairs in the +B-INJ wire segment. Depending on the findings, either repair the wire or replace the fuse, ensuring electrical safety and system functionality going forward. In this follow-up, turn the ignition to the on position while ensuring that the injector relay remains disconnected. Measure the voltage across the injector relay socket pins, particularly focusing on the INJ RLYCL line. This measurement aims to check for battery voltage momentarily, as this signal is essential for the real-time operation of the injectors. If battery voltage is detected, it indicates that the wiring from the relay to the socket is operational. And you can move forward in the diagnostic process. If there is no voltage present, further investigation into an open wire condition in the INJ RLYCL line becomes necessary, requiring careful examination of the associated wiring and connections. In this troubleshooting stage, begin with the vehicle in the off mode and ensure safety by jumping the SCS line using HDS before proceeding. Disconnect the PCM connector A51P, which is vital for wiring checks. Check the continuity between the test points across the INJ RLYCL line. This continuity test verifies if there is a solid connection present between the injector relay and the powertrain control module, PCM. A positive result confirms that the INJ-RLY-CL line wire is functional, while failure to register continuity indicates that further action to repair any open wire conditions will be required. In this step of the troubleshooting process, turn the vehicle ignition to the off position. Connect the terminals of the injector relay 4P socket using a jumper wire. Jump the SCS line with the HDS for safety, and then measure the voltage between specified test points. This check aims to ascertain if the INJ relay outline is delivering battery voltage correctly. If battery voltage is confirmed, it indicates that the wiring is sound, and you can proceed to follow-up steps. If no voltage readings occur, it implies a problem exists in the INJ relay out wire, necessitating further diagnostic actions to identify the issue. For this step, recheck the DTC status using the HDS following the voltage checks on the injector circuits. If DTC P0202 still appears, it confirms that corrective actions are needed in the circuitry for the number 2 injector. Proceed to the next steps, which include further diagnostics surrounding the injector circuits. If the DTC P0202 does not appear, refer to additional tests to determine whether another component or failure type is responsible for the injector malfunction. It is crucial to ensure the accuracy of these readings to direct the troubleshooting path effectively. In this key step, ensure the vehicle is powered down, then reinstall the injector relay for correct function. Use the HDS to jump the SCS line to ensure safety during the checks. Proceed to disconnect the PCM connector B51P to evaluate the transistor outputs. Measure for continuity across the INJH2 and INJL2 wires, as these correspond directly to the number 2 injector circuitry. Successful continuity indicates no issues in the wires, allowing you to proceed to follow-up checks. Any failure in this continuity would task you with finding and repairing open circuits in either the INJH2 or INJL2 wiring. Following successful continuity on the earlier lines, disconnect the number 2 injector 2P connector from the assembly. This essential action prevents cross-circuit impedance while enabling focused testing of the INJH2 wire. Conduct a continuity test between the specific points to ensure the continuity of the wire. If continuity is verified, it confirms that the INJH2 wire is operational, allowing you to progress to further checks. However, if failed, immediate attention must be directed to locate and rectify the open wire condition present in the INJH2 circuit. This step entails checking the continuity of the INJL2 wire, continuing the thorough inspection of the injector circuits. Similar to earlier checks, ensure connectors from the PCM and injector remain disconnected during testing. Measuring for continuity here ensures that the wire responsible for injector signal delivery is intact and functioning. If the check returns continuity, you can confirm normal operation of the INJL2 wire. But any loss would require investigation for potential problems along that wire's route. If both INJH2 and INJL2 signals return healthy tests, it indicates a failure in the number 2 injector, demanding replacement of all injectors as a complete solution for reliability. In this troubleshooting step, begin by disconnecting the number 2 injector connector once more to allow separate testing. Turn the ignition to on mode to power the respective circuits within the engine management system. Measure the voltage across the designated test points for the INJH2 wire to see if power flows correctly from the PCM. This test is vital to ascertain if there's any misplaced power that could short-circuit the wiring. Presence of voltage in this measurement indicates a short to power, necessitating the need to rectify the issue. If no voltage appears, you can proceed to check the general circuit's continuity to identify any flaws in the wiring pathways. This step evaluates the INJL2 wire's integrity similarly to the previous check, measuring essential voltage output while keeping the ignition in on mode. By assessing voltage at the connection points, this diagnostic aims to uncover any shorts that could disrupt the injector signal pathways. If voltage is confirmed, this signals a short to power in the INJL2 wire, which needs immediate attention to prevent further complications in the injector operation. In scenarios where no voltage exists, continue troubleshooting procedures to trace the wiring until resolution is achieved. This sequence builds a comprehensive understanding of both the wiring and component functionalities as critical operational feedback. For this follow-up, return the vehicle to the off mode, ensuring all components are safely powered down. Check continuity on the INJH2 wire, focusing on connections between the relevant terminals. The follow-up test here is paramount, as identifying continuity signifies no issues in the wiring are present, which is crucial for ensuring reliable operation of the injector. If continuity is found, you can conclude the INJH2 wire is functioning well. But if not, further investigative measures should be taken to repair the identified open circuit in that particular wire's run. This step performs a continuity check on the INJL2 wire, similarly to previous continuity checks. Maintaining the vehicle in the off mode allows focused testing without risking electrical crosstalk. Confirming continuity during this assessment provides evidence of proper circuit function, while a failure mandates further investigation into the INJL2 wiring for faults. If both INJH2 and INJL2 circuits function correctly, yet issues persist, it advises replacement of the entire set of fuel injectors to ensure uniform performance across all cylinders, enhancing reliability and efficiency. In this troubleshooting phase, disconnect the number 3 injector connector to isolate it for focused testing. This entails checking the continuity for the INJH3 wire, which is vital in delivering signals for the 3rd cylinder fuel injector. By measuring the continuity successfully, you confirm operational integrity for that circuit, allowing you to proceed confidently. If the INJH3 wire is confirmed operational, affirms reliable operation of the injector. Yet absence of continuity indicates further troubleshooting in that specific wiring segment is imperative. This step emphasizes the importance of ensuring all wiring connections across cylinders are functional to prevent further faults. This essential troubleshooting step checks for continuity in both the INJH3 and INJL3 wires, ensuring communication between these wires while keeping the vehicle in the off mode solidifies trustworthy operation across the injector circuit. A successful continuity result indicates effective wiring paths, allowing you to move forward with testing. However, a lack of continuity suggests disruptions in the wire, leading to further diagnostics for locating issues. Always ensuring that these connections are confirmed to be clear and functional helps maintain reliable engine performance. Upon completing repairs related to DTCs P0202 and P0203, follow up with a final verification of the system status. This includes rechecking the DTCs using the HDS to confirm that no errors remain associated with the injector circuits. If DTCs are cleared and do not return, ensure to perform a test drive to observe engine performance under real driving conditions. Monitor for any signs of issues such as misfires or poor acceleration to confirm that all repairs have rectified the underlying problems effectively. This final verification solidifies the repair's success, ensuring the vehicle operates seamlessly moving forward. To help prevent future issues with DTCs P0202 and P0203, regular inspections of the fuel injector system should be prioritized. Maintaining the cleanliness of connectors and ensuring they are securely fastened minimizes the risk of electrical faults arising from loose or corroded connections. Additionally, it's paramount to keep the powertrain control module, PCM, software updated, as updates can enhance the functionality and reliability of the system with improvements or bug fixes from the manufacturer. Lastly, establishing a routine maintenance schedule to check wiring continuity and relevant fuses can help detect potential problems before they escalate into significant failures. Together, these preventative measures foster a more robust vehicle performance and extend the lifespan of key engine components. In conclusion, DTCs P0202 and P0203 signify critical injector circuit malfunctions that can severely impact engine performance. A methodical troubleshooting approach is essential, starting from verifying DTC presence through various electrical checks, wire inspections, and relay functionality. Each step enhances your ability to accurately diagnose and repair the underlying issues effectively. Regular preventive maintenance, including inspections and timely updates, plays a significant role in safeguarding against future occurrences of these codes. Educating vehicle owners on the importance of addressing such DTCs promptly can improve overall vehicle health and longevity, ensuring a smooth driving experience. Please like and subscribe to the channel. See you next time.